Hi, my name is Sarah Fleckenstein, and my final research project for urban informatics is how different land uses influence biodiversity within Austin, Texas. It is well researched that land use changes interfere with the health and quality of naturally occurring ecosystems. Humans play a large part within urban ecosystems through their interactions, manipulation, and use of the land. Austin is a good case study because it includes diverse land uses and is within a unique climate between the desert of the American Southwest and the lush green American Southeast. Austin also devotes 10% of the land to green space, which includes the Barton Creek Greenbelt that includes diverse habitats that support biodiversity. The study population came from iNaturalist plant observations that are grouped by species. There were a total of 121,743 plants observed and 2,140 different species. The land cover comes from the U.S. Geological Society National Land Cover data, and each color represents a different land use. The red is representing the developed land at different intensities. Through ArcGIS Pro, and I converted the national land cover data to a GeoJSON and spatially joined that with the iNaturalist plant observation within Python. I used different Python libraries to project a land use map and different bar graphs to analyze the different species. The results showed that the most plant observations were found within the evergreen forest land cover class that had substantially more observations than the next top land cover classes. The next top land cover classes were developed low intensity land, developed medium intensity, developed open space, and developed high intensity. I measured biodiversity by species richness, which is the number of species observed within an area, and then the species richness showed different outcomes because they're much more evenly distributed. The land cover classes with the most biodiversity were the developed low intensity, developed medium intensity, then the evergreen forest, developed open space, and developed high intensity. More biodiversity is found within the lower intensity developed land than higher intensity developed land, which supports my original hypothesis that less development creates a better environment for plants, more biodiversity plant species. But the natural land classification did not have the most biodiversity. Most of Austin, Texas is zoned for single-family housing, which is represented by the developed low intensity and medium intensity. This was shown in the map here. This may influence the number of observations within these land classes because they have the most area of the city. The much higher number of plant observations were within the evergreen forest land classification, which could show that the iNaturalist users were visiting parks and more aware of the plants around them and more likely to open up the app. In conclusion, it is very important to think about how land use changes the ecosystems and biodiversity in urban areas. iNaturalist creates a great opportunity to teach people about species, natural systems that exist everywhere in natural and developed land. The city of Austin can support biodiversity in developed land, more specifically in high density developed land by planting street trees, including green infrastructure in urban design and educating people about the importance of urban ecosystems. In the natural land use types of Austin, the city could work on land restoration and conservation efforts to strengthen the biodiversity and health of the local ecosystems in natural land covers. Thank you for listening.